Okay, you guys, same directions. We want to use the substitution method to solve the system. Now, is there an obvious way to do this one? It's y equals negative 2x plus 3 for one equation and 2y plus 4x equals 6 for the other equation. Yeah, this looks like kind of like the first problem. We've got, in this case, the first equation solved for y in terms of x. So it makes sense to plug in what y equals, negative 2x plus 3, in for y in the second equation. So in the second equation, in place of that y, put in a set of parentheses. Everything else stays the same. And then in that set of parentheses, replace y with what it's equal to, negative 2x plus 3. Now, are the parentheses necessary in this one? Yeah, because they remind you to do what with the 2 on the outside? What do you do with that 2 on the outside?
Distribute it.
You need to distribute it. And if you distribute it, what do you get? Negative 4x plus 6 plus 4x equals 6. Now what happens when you combine like terms here? Negative 4x plus x on that same side, on that left side? They knock each other out. And you get the statement 6 equals 6. It is a true statement. So what happens when you do everything right and you get a true statement? That means you have a dependent system. It means the lines coincide. And by the way, you could see that pretty easily by solving this equation for y. It would turn in to the top equation if you solved this equation for y. So you've got a dependent system. If you were to graph the lines, they would lie one on top of another, right? So this is a dependent system, which means every ordered pair on the line that either one of these equations graphs to be, every ordered pair is a solution. So how do you write that down? So it's obviously a set. The solution is a set of ordered pairs, right? So we start with the curly bracket, the set of all x, y, vertical bar means such that. In English, we're saying, okay, the solution would be, the solutions would be a set of ordered pairs x, y, such that what? You could write down either equation. I'm going to write down the top one. Such that y has to equal negative 2x plus 3, which is just a fancy way of saying, hey, x and y have to lie on the line. They have to lie on the graph of the line. Because every ordered pair on that line is a solution. So dependent system, there's an infinite number of solutions, and this is how you characterize the infinite set of solutions.